Okay, now chapter 6 questions. Number 5, the number of emails received on a given day, is it discrete or continuous? Discrete if you can count them as 1, 2, 3, 4, 5, etc. Continuous if you can't. Number of emails, yeah, I can count how many emails I receive per day, so that would be a discrete. Some examples that you cannot count anything that you measure using a tool, like weight, age is not countable, so it's continuous. Height is continuous. Amount of water you drink a day is continuous. Amount of gas in a gas tank is continuous. But anything that you can count as 1 and then the next number 2, 3, 4 is discrete. Next question. All right. Number 6. Given the table of probability for a random variable x, does this form a probability distribution? Answer yes or no. You will have a probability distribution if each probability right there is between 0 and 1, and if you add them up you get a 1. So is each probability between 0 and 1 here? As you can see, this is true, but if I add them up, do I get a 1? Let's see. 0.02 plus 0.07 plus 0.22 plus 0.27 plus 0.42. So what do they add up to? So that's 9 and 22 is 31, 51, 58, 42. Yes, they add up to 1. So this is a probability distribution. So the answer is yes here. Next question. Consider the discrete probability distribution to the right when answering the following question. Find the probability that x equals 4. How would you find the probability that x equals 4, guys? Well, we know the sum of the probabilities must equal to 1. So the missing value is, what should that number be in order to add them up and get 1? So that would be 1 minus 0.27 plus 0.03 plus 0.33, which is 1 minus, if I add those, I get 0.63, and that should give me 0.37. So that should be the answer. Number 8. Calculate the mean of the discrete probability distribution. The mean is given by this formula, guys. XPX, which is 2 times 0.2 plus 3 times 0.3 plus 7 times 0.3 plus 9 times 0.2. So if you do the math using your calculator, you get 0.4 plus 0.9 plus 2.1 plus 1.8, and let's add them up. 1.3, 1.4, 3.4, 4.4, 5.2. That is the mean, and that's the formula. I'm going to show you how to do this one also using the calculator in the next exercise. Number 9. A dice game involves throwing 3 dice and betting on one of the 6 numbers that are on the dice. The game costs $6 to play, and you win if the number you bet appears on any dice. The distribution for the outcomes game, including the profit, is shown below. What's the expected value? So what's the expected amount of win or loss? It is the mean. It is the same, guys, as the mean. It's called the expected value. So that would be negative 6 times 125 divided by 216 plus 6 times 75 divided by 216 plus 8 times 15 over 216 plus finally 18 times 1 over 216. And I'll let you do the math. You can check the answer in the back. So that's how you do it. It's the same as the mean, which is sum of x times px. This is the x right here, and this is the probability. These are the number of dice, so I wouldn't worry about that. That has nothing to do with the problem right here. Number 10. The random variable x represents the number of computers the family have along with the corresponding probability. Find the mean and the standard deviation of the random variable. I'm going to show you how to use a calculator here. The mean is this, sum of x px. If you do it by hand, it will be 0 times 0.49 plus 1 times 0.05 plus 2 times 0.32 plus 3 times 0.07 and plus 4 times 0.07. Then you do the math to get the answer. Now let me show you how to use the calculator for this one. So please pay attention to this. First of all, you go to stat, edit, and you put the x values in L1 and the y values and the px in L2. So I'm going to do them right now. 0, 1, 2, 3, and 4. Now I'm going to go to L2, clear it first, enter. 0.49, you'll see how easy it is. 0.05, 0.32, 0.07, 0.07. Okay, now watch and see how we can get the mean and the standard deviation, or the expected value. The mean or expected value is the same. So you got stat, calc, one variable statistic. If you see this window, guys, that means you have a newer calculator. Here's what you do. For list, you make sure it's L1. For frequency, you enter L2. Let's say there was no L2 here. How do you enter that? You press the second key and then number 2. And then hit calculate. Look, X bar is 1.18. This is the mean. So I know the answer now is 1.18. And the standard deviation, you can see it. It's right here. Sigma X. It's 1.299. Now if you have an older calculator, guys, and you don't get this screen right here, if you didn't get this screen, this is what you're gonna get. You're gonna get this when you press one variable statistics, you're gonna get this screen, this number. So this is what you do. You press the second and then number 1, that will input L1, then you put a comma, and then you press the second and then number 2, and you get L2. You do one var, L1, L2, and that will give you exactly the same thing that I got using the previous screen. So this is how you do it using technology, using calculator. Number 11. Decide whether the experiment is a binomial experiment. If it's not, explain why. You observe the gender of the next 600 babies born at the local hospital. The random variable represents the number of boys. Okay, a binomial experiment has 3 conditions. First of all, you have to do it fixed number of times. Since we're testing 600 babies, so that's fixed, 600. So that's the first condition met. Second condition, you have to have 2 probabilities. One is success and one is failure. Well, we will win if we get a boy. What's the probability of getting a boy? It's 1/2. So that's success, and the failure is 1/2 as well for girls. Does this probability change from one outcome to another? If it doesn't, then we have a binomial experiment. Well, yes, the probability of a boy is always 1/2. It doesn't change, just from one person to another. So it is a binomial experiment. Next question. Decide whether the experiment is a binomial experiment. It's not, explain why. Selecting 5 cards, one at a time without replacement, from a standard deck of cards. The random variable is the number of picture cards obtained. Well, if you select 5 cards, you can get 0 picture, 1 picture, 2, 3, 4, or 5. So this is a discrete variable, but is it a binomial experiment? Okay. When you select the first card, what is the probability of getting a picture? Well, there are 12 pictures in the cards. So the probability of getting 1 picture is 12 out of, there are 4 queens, 4 kings, and 4 jacks. So it's 12 out of 52. So the probability of success is 12 out of 52. But when you don't replace, the card, and then you draw another card the second time, your total is not 52 anymore. So it's going to be 51. So your probability of success is going to change as a result of that, and then in this case, this is not a binomial experiment. So that was a yes for the previous one, and a no for this one. Next question. 13. In a recent survey, 75% of the community favor building a health center in their neighborhood. If 14 citizens are chosen, what's the probability? Exactly 9 of them favor the building of a health center. I'm not asking you to do any work by hand. For exactly, guys, there is a formula on the calculator. It's called binomial PDF, and that's the formula that I'm going to use. It needs 3 arguments. It needs the value of n, which is here what's the total? 14. It needs the probability of success, which is 0.75, and it needs the value of x. He wants exactly 9. If he says 8, you make it 8. If he says 7, you make it 7. So it's 9 here. So probability of x equals to 9. Here's how you do it on the calculator. Watch. Second key, variables, and you scroll down to binomial PDF. Okay. Trials, how many trials do I have? It's 14. What's the value of p? 0.75. And the x value is 9. Paste. Now guys, if you don't have the newer operating system, you're going to get binomial PDF when you press on binomial PDF and parentheses. So you fill in between parentheses. You put 14, then comma 0.75, then comma 9, and you should get the same answer. So the answer is 0.1468 if we want to do 4 decimal places. Next question. 14. Assume that male and female birth are equally likely and that the birth of any child does not affect the probability of the gender of any other children. What's the probability? Exactly 9 girls and 10 birth. So x is 9, n is 10. He didn't give us the probability of success, guys, but we know what's the probability of getting a girl. It's 1/2, so it's 1/2. So probability of x equals 9 equals binomial PDF. Exactly, you have to use a PDF. So n is 10, p is 0.5, a half, and then 9. And let's do that on the calculator. Second distribute. Scroll down to binomial PDF. N is 10, p is 0.5, x is 9. Paste is 0.0098. Alright, number 15. 50% of the people that use internet order something online. So this is a P, probability of success. Once he begins with the percent, guys, I'll give you a percent of the problem. You know it's not a normal question, normal probability question. It's chapter 6. It's a binomial probability. So P is 0.50. Find the probability that only 5 of 10 internet users will order something. Again, exactly 5 out of 10. So x is 5 and n is 10. So it's binomial. It's a probability of x equals 5. It's binomial PDF. N is 10. P is 0.5. And x is 5. Again, guys, if you use your calculator, just do the same thing as I did earlier. What's n here in our case? 10. 0. Just changing the value of 9 to 5. 0.2461. Number 16. Assume that males and female birth are equally likely and that the birth of any child does not affect the probability of the gender of any children. Find the probability at most 3 girls. Now at most, guys, this is a different formula. At most means less than or equal to. So pay attention to this. So we need a probability of x less than or equal to 3. It's not a binomial PDF, it's a binomial CDF. CDF stands for cumulative. You need again n, which is 10. You need a probability of success. He didn't say it, but we know if it is a gender, it's 1/2. And then you put the value here, which is what? 3. So this is how you do it with at most. And let me show you now on the calculator. So you go to second, distribute. You're going to see the at most is below the PDF, the binomial CDF. And then trials is how many we said total? Yeah, 10. Oh, the 10 is popular here. P is 0.5 and at most 3. If it says at most 4, it's just for do 4. 0.1719. Number 17. According to the Federal Communication Commission, 70%, so the 70% guys is the probability of success, of all US households have VCRs. In a random sample of 15, so n is 15. What's the probability that exactly 10 have VCR? So probability of x equals 10. Again, exactly is not CDF, it's binomial PDF. So you get n is 15, p is 0.70, and then put 10 there, and let's see what the answer is. So I'm going back to PDF. Trials is 15, p is 0.7, and x is 10, 0.2061. 18. According to the Federal Communication Commission, 70% of all US, so that's a p. In a random sample of 15, that's n. What's the probability the number of households is between 10 and 12? Oh, probability of x 10 and 12 inclusive. So that means the probability of 10 or 11 or what? 12. Here's what you can do, guys. You can run binomial PDF on 10, binomial PDF on 11, binomial PDF on 12, and then add up the three answers. So I'm not going to do it. It's x10 plus x equals 11 plus x equals 12. You have n. N is 15 and p is what? 0.70. So you change one time x to 10, 11, and 12, and then you do it 3 times and you add them up. 19. A recent survey found that 70% of all adults over 50 wear glasses, so that's a p. In a random sample of 10, that's n. What's the probability that at least 6 of them wear glasses? Okay, at least 6. How do you write at least 6? Greater than or equal to 6. That means it's what's greater than or equal to 7 in the discrete? What's the number that comes after 6 in the discrete case? It's 7. There is no decimals in the discrete case. So it's 7 or 8 or 9 or what? 10. You have 2 ways to do this. You can do the 7 on the PDF, the 8 on the PDF, the 9 on the PDF, the 10 on the PDF, and then add up all the answers. Or you can do this. 7, 8, 9, 10, that's what I want. But what I don't want is the 0, 1, 2, 3, 4, 5, 6. These I don't want. And these I can find using the at most. That means this is at most 6. At most 6 is a binomial CDF. So I can do binomial CDF. N is what? 10. P is 0.70, and then 6, and let's see what the answer is, and then I'll tell you what we're going to do with this answer. We're getting what he didn't ask for. So trial is 10, 0.7, and then 6, 0.3504. This is this, guys. This is the probability of getting a 0, 1, 2, 3 all the way up to 6. But he wants 7, 8, 9, and 10. Well, since we were able to use the calculator to do 6 and less, to find 7 and up, you just subtract the answer that we got from 1. So our answer, 1 minus 0.34504. Which is 0.6496. That would be your answer. Number 20. A quiz consists of 440 true or false questions. That's n. What's the probability of success for true or false? It's a half. It's 50-50. If the student guesses on each question, what's the mean number of correct answers? Well, the mean, there is a formula, guys. You will be provided with the formula. It's n times p. Well, your n is 440 and your p is 0.5, so that will be 220. 21. According to government data, the probability that an adult was never in a museum is 10%. In a random survey of 100 adults, what's the mean and the standard deviation of the number who were never in a museum? Same thing. So n is 100, p is 0.10. What is the probability of failure, guys? If 10% is success, then 90% will be failure. So the mean will be NP, which is 0.1 times 100, which is 10. Standard deviation, there's a formula for it. It's a square root of NPQ. So there is no calculator program to do this, but it's very easy. You do 0.9 times 0.1, which is success, 0.9, which is failure, times 100, and then you compute the answer. That concludes the questions from chapter 6. So I will stop the video here and do another one for the normal probability, which is chapter 7 now.